All right. So you want to figure out which angles are equal, right? So I suggest that you guys pick one trig ratio and go with that one. So I think we all tried sine. Is that right?
Yep.
Yeah. So sine of A, long, what is it? Good, 305. Sine of B, what is it, Tony? No, you can do it. What's opposite B? 4. What's the hypotenuse? 5. Good, 4 or 5. Do we do sine of C? No, because sine of C is the 90-degree angle. We don't sine 90-degree angles, right? All right, next one. Oh, fumbled. Sine of F, Bruno. We can do F. Good. Sine of D, David. You have no clue. What's opposite D? 12 over 13. I think you have no clue. You guess. Well, good guess. Keep guessing. All right. Sine of E, Maddie.
5 over 13.
Good. G. Sine of G. Who's next? Andrea. Good. Sine of H, Luis. Same thing. Interesting. H, I. Sine of I, China. We can't. Okay. Sine of J, Kendra.
24 over 26.
Good. 24 over 26. Okay. Sine, oh, K's over here. Sine of K. Who's next? Naya. Sync. That's funny. Nice job, Whitney. What's opposite K? 10, because if I draw this, 10's out of it, right? Touches these two, so 10's opposite. So 10 over what's hypotenuse? 26, good. Sine of L, Justin. No, we don't do it, it's a right angle. Okay? Whitney, sine of N.
8 over 10.
Jamira, sine of M.
M?
Yes.
Or N.
M.
What?
Did you just ask me N?
Oh, no.
Yeah, you asked for M.
Okay. 8 over 10 for Whitney. Sine of N.
6 over 10.
Good. Okay. Sine of O. Jessica. Can't do it. Good. Any questions about how I got those signs and those signs, guys? Any questions? Alyssa, do you know any angles that are equal? G and H. How do you know G and H are equal? Good. G and H are equal because their sine ratio is the same. Okay. Serena, do you know any other ones that are equal? You don't think so? Does anyone see any other ratios equal? If you have one, raise your hand.
Are we supposed to simplify them?
You can simplify them. So, like, what does 6 over 10 become then, Jamira? 3 over 5. Interesting. What is 3 over 5? Is that shown up before?
Yes.
Sine A. So which ones are equal?
Sine N, sine A.
Good. So A equals N. Where can I write these? We're over here. So we had G equals H. We had A equals N. What else? Anybody? B and what? B and M. Good. Whitney and Long, thank you. And the other ones? No. And yes, I know all the right angles are equal, so you're going to tell me those ones. There's nothing else?
Yes. D and J.
D and J. Because sine of D was 12 over 13, sine of J is 24 over 26. 24 over 6 reduces to 12 over 13, right? If you don't believe me, do 13 or 12 divided 13 and 24 divided 26. You'll get the same decimal. So D equals J. Are there any other ones? D and K. Or E and K. I think I said P as like, there is no P. We didn't go that far. Alright. Any other ones? No. Okay, one quick thing I've noticed. If A equals N, then its complements are equal, right? Right, remember A and B add to 90, N and M add to 90? Okay. Same thing over here. D equals J, so
E and K.
equals K, right? And G and H equal each other and their complements. So what two numbers equal each other and add to 90?
40.
There you go, 45. Okay. 45 and 45 add to 90, right? So E and H are 45. Sorry, G and H. I said E and H. G and H are 45. Okay. Guys, this make sense?
Yep.
Yeah. Now, if I use cosine, would I get the same results or different results?
Same.
I get the same results. If I use tangent, I get the same or different results? Same. Okay. Any trig function, I get the same results. Does that make sense?
Yep.
Okay. So, two angles are equal if the ratio of their side lengths are the same, right? Let's try the next part. The next part you want me. You have one more part of your warm up. Right down here. Says you need to finish this sentence. Finish the sentence. In triangle ABC and DEF, measure angle A equals measure angle D as long as what? As long as negative 12, is that what you said? Yeah, I think that's the answer. So if A and D are equal, talking about big A and big D, if those are equal, what has to be true? Okay, B equals E. That's kind of a result of A and D being true. Okay, but in order for A to equal D, what has to be the case? Ratio. What ratio, Luis? Pick one. You have three choices. None of them are wrong. Pick one.
Sine.
Sine. Thank you. What is sine of A?
A over C.
A over C, right? What's sine of D? D over F. Now, in order for these two angles to be equal, what has to be true about these two ratios? Equal. Good. Well, we just did above, except now we're using letters. Right? Which trig function was this? Sine. So this has to be the case. Or, does anybody know another one? What's my ratio that could work? We just did sine, but cosine. What would cosine give me, Jamira?
Well, which one are we looking at? What number?
A.
What?
Oh, you're wrong. Adjacent hypotenuse.
B. Oh yeah. B over C.
Good. So B over C has to equal what? Someone help us out with that one. Maddie, help us out with D. What's cosine D?
Cosine D.
Yep.
E over F.
E over F. Perfect. And that was cosine, right? So that could be the case. What's the last one? Tangents. Right? Tan ratio. Everybody know it? What's the tan ratio for A? A over B. What's the tan ratio for D? D over E. Good. So, if any one of these ratios are equal, then what do we know about A and B? Or A and D? They're equal. Okay? If any one of those ratios are equal, then A equals D. And it actually follows that if this one's equal, if the sine ratios work, so will cosine and tangent. If tangent works, so will cosine and sine. If any of those are equal, A and D are equal. And the reason being, Sine, cosine, and tangent, they are constant ratios for a specific angle. Right? Is that a new piece of information? No. We know that, haven't we? Sine and cosine and tangent are constant ratios, Maddie, for a specific angle. We already know that. So the next question is, how do we find that angle? We don't. We just say, okay, I'm good. And that's enough, Mr. Branch. We're done for the year.
Yeah.
No, that's not what we do.
No, I can understand.
It's not what we do. Finally get it, right, Jemima? I finally learned. So, the way we find that angle is by using something called inverse trig function. Okay? This is on the back of your paper that I gave you. Okay? So, inverse trig functions. Inverse trig functions, I think, are kind of fun. But then again, I think most of the stuff we talk about is fun, and you guys tend to disagree. Okay? So, inverse trig functions. Inverse trig functions, they are used to find angles when we know the ratio of the side lengths in a right triangle. So, on the first warm-up question, did we know the side lengths?
Yeah.
Could we write ratios for the side lengths? So since we know the side lengths and we can write ratios, then we can actually find the angles. And now we find the angles by using things called inverse trig functions. Okay? Now, in order to use these inverse trig functions, you must be in degree mode. That's because we're used to finding your answers in degrees. Make sure you're in degree mode. Remember, hit mode. Make sure you're in degree. And once we know we're in degree, we can use inverse trig functions to find angles when we know the ratio of the side lengths in a right triangle. Okay, so write that down real quick. Write down what we use inverse trig functions for. And I'll show you what an inverse trig function is. Yep. Not right now. Once you're done with this one, then you can kind of miss a big point if you go right now. All right, so I'm gonna move this up. Everybody got the definition written down? We got that written down. The use to find. C. I'm looking for part C now. All right. So example: sine of A equals 3/5. We know that, don't we? Sine of A was 3/5, right? So how can I find A? How can I find A? Well, if I had something that was like 2x equals 10, how can I find x? Divide by 2. It's the opposite of multiply, because 2 times x is multiply, right? Divide by 2, get x equals 5. So we need to have the same kind of backwards function for sine. Well, that's what sine inverse is. Okay? So if I know that sine of A equals 3/5, I can get rid of the sine by doing what's called inverse sine. Right? You don't need to write the step, but you can think about it like this. If I were to do inverse sine of the sine of A, if I do it to the left side, I have to do it to the right side as well, don't I? That's how algebra works. Whatever you do to one side, you have to do the other. So I need to take the inverse sine of 3/5. Now what inverse sine does is it cancels sine. So what am I left with? A. And A is an angle measure, isn't it? Yeah. So I'm left with A equals the inverse sine of 3/5. And that is how we find angle measures when we know the ratio of the side lengths. Okay? So to find inverse sine, you hit second sine on your calculator. So second button's top left corner. We all know where sine is, right, Andrea? Okay, so hit second sine. 3 divide 5, enter. And what you've just done is found an angle measure from the ratio of the side lengths. You guys are fancy now. Okay. Oh, we're using sine. Second sine. Sine. Okay. So it's second sine, and they'll give you the inverse sine. Okay. So, what's the inverse sine of 3/5? So 36.87, right?
Yes.
Right? Does that make sense?
Yeah.
Are there any questions? No. Okay. I want you to try the same thing, but now I want you to use cosine of A and tangent of A. If I'm using cosine of A, do I still use 3/5? No. What do you use for cosine, Tony? Four-fifths. Okay? So I want you guys to find A using cosine and find A using tangent. No, we're not done yet. Cool thing called lunch. I just had lunch. Ordering lunch. Justin, if you finish cosine and tangent, it's right. I'll let you go. Nope, you have to sign afterwards. Did you say you have to sign afterwards?
No, the same answer.
Should you? What do you think?
Yeah.
Did I change angle A? No. So did you get the same answer?
Yeah.
Because angle A is still the same. Right? We can make the angle bigger or smaller when we switch to cosine. Right? So it should be the same. Alright, so how do I solve this one? How do I find A? Do I use inverse sine? No, we use inverse cosine. So A equals the inverse cosine of 4 over 5. What's the inverse cosine of 4 over 5? 36.87. Good. Tangent. Tangent of A equals? Tangent of A, what's the ratio? 3 over 4. Thank you. So now to solve for A, we use inverse tangent. And the inverse tangent of 3/4 is 36.87. So we got the same angle regardless of which ratio we used. Right? So all three ratios are a valid way to find an angle measure. Does that make sense? Do the inverses make sense, guys? Yeah. Any questions? No? Okay, you may go now, Justin.